Number 6, this is a graphing calculator question, and it would be really nice if I could put this, put my graphing calculator in this video, but I can't really do it, so I apologize. This question, I have a river, and what I'll do is I'll make my fence in yellow, or sorry, orange. So I've got a fence that butts up against the river like this. And I want that fence to kind of be as big, to enclose as much area as possible. So, and then I have 4,200 meters of fencing to put around in that orange, along that orange, those orange lines there. So it says let x be the side length perpendicular to the river. So I'm going to let that be x. Now if it's a rectangle, then this opposite side is also x. So I'm going to do some work down below here to kind of figure out some parts of this thing. So I'm going to call that side y, and if you can already see where to go from here and what that is, then that's good. But if not, just kind of follow along here. They tell me that I have 4,200 meters of fencing. I want an equation, a function, that's based on x. So I want to know what is a of x. That's what part A is asking me. So I need to have this side right here be in terms of x. So I'm going to call it y for now, and I know that all of those orange lengths add up to my 4,200. So I can write 2x plus y equals 4,200, because that's those lengths all added up. Then I can subtract the 2x on both sides and get y equals 4,200 minus 4 minus 2x. Notice that's what I have here, this y. So I'm going to replace the y with this, because then it'll be all in terms of x. So you can see here that I've got my side lengths labeled, and so I've got these two side lengths labeled. I've got x and 4,200 minus x. I know that area is length times width, so the area of this plot in terms of x is going to be the bottom, which is x, times the side, which is 4,200 minus x. So that's the answer for part A. I've got that done. I'll cross it out. The next thing it asks for is what is, sorry, that's 2x. I didn't write that right. 2x. That's what I had written down over here. Alright, so I've got A done. Now, the next question is, what is the realistic domain? So the domain is the different values that I could have for x. So it should make sense that I'm going to have an x value that's bigger than 0, right? So I'm going to be starting at 0, but I could really have, like, if I really wanted to, I could make it 0.01, right? I know that doesn't make any sense really in terms of like actually having a fence and a river or whatever, but hypothetically, if I really wanted to, I could make it really, really, really small. My upper end is going to be as if I had a really, really long piece coming out this way, and I had my river right here, and then I had another really, really, really long piece coming out this way, and then a tiny, tiny piece right here. And what that would do was leave half of the 4,200 for this length and then half for this length. So what I can do is divide 4,200 in half to get 2,100 as the upper end of my domain. So that's my realistic domain for this question is from 0 to 2,100. The next question asks what's an appropriate window for graphing the entire function. So I'm going to try to walk you through this a little bit. We've done a lot of it in class, so I'm not going to take too much time. But the whole reason I find this 0 to 2,100 is because that's my x's. So maybe I'll write, so this is my answer for part C. X goes from 0 to 2,100. So now I need to figure out what y goes from, to and from. So to do this, what I'm going to do is go to my calculator, and I've got one right next to me right now, right next to my iPad right now, and I'm going to type some numbers in that are kind of in the middle of that 2,100. So I could go 900 and I type that in. And I could go 1100 and I could go 1100. Each of those give me numbers that are kind of like up near the 2 millions. My calculator says 2.2E6, so I typed those two numbers in, and if I scroll over with my arrows to the right to underneath the Y, then it'll show me what that number is there. What that tells me is that my Y's get up to at least that much. And I can plug more in, but I'm just going to kind of say, alright, that seems like it's good enough. Now I'm going to go to my window. I hope you're doing this with me. And I'm going to take my x's. Let me actually give myself a little bit more space here. My x min is going to be 0. That comes from my domain. My x max is going to be 2100. So I'm going to go ahead and type that in right now. 0, 2100. I'll count by 100. It doesn't matter that much. Now, my y min. My smallest y is going to be 0, because that would be like having one of those two ends, where either I have like a 0, x equal to 0, or x equal to 2100. So my y min is going to be 0. My y max, the whole reason I have this table and I use this table feature is because this gives me a really good clue at what my y max is going to be close to. What I like to do is look at these numbers that I have here and then round up a whole lot. So this has 20, well, not a whole lot. Round up, what I say is round up generously. So that's 2.2 million. So what I'm going to do is type in 2.2 or 2.5 million. So my y max is going to be 2,500,000, like that. So I'm going to type that in right now. 2, 5, 1, 2, 1, 2, 3, enter. I don't really care what I count by because it doesn't matter that much. I hit my graph button and it shows a nice, actually hold on. Make sure you have that window written down because I'm going to erase it right now. So what I get is this nice looking, kind of looks like a parabola, graph, whatever, that kind of goes up and then comes back down like this, and it fits perfectly in my window, the one that I just erased that you should have on your calculator. So now what I want to do is hit second and then hit the trace button, which is second calc, and go down to maximum. That's the fourth option. This is all on my calculator. It'll take a little cursor. It'll ask for left bound. So I'm going to go kind of to here and go to the cursor. I'm going to scroll left, and then I'm going to hit enter. And it'll leave a little X there. And then I'm going to, or a little arrow thing. Then I'm going to scroll right, because it asks for right bound. So I'm going to go over to here, and I'm going to hit enter again. And now it asks for guess. So I'm going to get a little bit closer. So this was my left, my first one, my right, and now it asks for guess. So I'm going to kind of get up in that general area and hit enter. And what it does is it gives me a maximum, and mine comes out to be 1050. That's the x value of my maximum. So I'm actually entering E right now. We'll go back to D. So my x value that maximizes the area is 1050, and then the y value, which is the maximum area for that, comes out to be 2205 with 3 zeros on it. So I'll have my commas. So that's about 2.2 million-ish. So it's really close to what we had in our table earlier. I'll go answer D lastly. Actually, hold on. So D asks for what is the area when x is 1150. So this is actually really easy when I have the calculator with me. So I'm going to go to my table. You can either do this in your table or you can do it on the graph. I'm going to go into my table, and under x and y1, I'm going to type in 1150 and hit enter. And it gives me something with an E, so I 1150. If I scroll over and I can look over top of it, it says 2185000. So I have my commas. I should also add meters squared. So that would be the y value when x is 1150, and it makes the calculator do all the work for me. I don't have to type things in or get something wrong. So hopefully that helps you with that problem.